Everybody ready?
Yeah,
Are
ready.
you all ready? I can hear you. Are you all ready?
We are ready.
All right. Yes. Uh. hmm. Okay. Thank you, Mr. Host, for making me a co-host. Um. Okay. So yes. Just like it happened last week, I still will not be able to project what I'm teaching. So what I will entreat you to do is to have your notepad ready. Yesterday, I hope I communicated to you that
Hello, Doc.
what
Sorry for the interruption. I wanted to find out the problem that you have that you're not able to share your screen so that I help you with it.
I am using the phone rather than the laptop.
Oh, okay. But you
Uh-huh.
can, if you have the slide over there, you
No,
can
the
still share
slides
the
are not on
screen.
the phone.
Okay, okay.
Uh-huh,
Thank you.
uh-huh. I know some of you are technologically inclined, so I know you could have been of help, but I'm not having the laptop at the moment. So it's unfortunate each time I have to teach. I am not home. I'll try and see whether next week I'll be around. I'll be at my usual place. I usually don't carry the laptop around. Okay, so that is it. But don't worry, I'll provide you with all the slides. Um, as a reminder, I hope all of you, sorry, have seen the uploads I have done. I uploaded the whole of the chapter one yesterday. So those of you who are not aware, that is for your information. So go onto your page and download the chapter one. Okay. I also informed you before today. I think that was yesterday that you should have your mathematical set ready, and that you should have your notepad. You should be sitting close to your desk. You should have all your writing materials ready because um, we may delve into a few things, some uh, preliminary issues to do with plottings and so on. So get your mathematical set ready, your notepad and everything, so that when we get there, you'll be more than ready also to join us. On that note, we begin our lesson in the name of the Father, the Son, and the Holy Spirit. Amen. Yeah, so last week we finished chapter one, if you remember. We are moving on to chapter two. I've told you the book is in two parts. We have the surveying aspect and then the cartography aspect. The surveying aspect is what we are working on at the moment. The cartography aspect will start from chapter 4. All right. It will start from chapter 4. Yes, chapter 4 and 5 will cover the cartography version. So I'll try my best within the 4 hours to finish. Is it 4 hours or 3.5? To finish at least a unit every week. But as I told you, I'll need some additional time apart from what has been allotted to, because the plotting alone, because it is not face to face, the plotting alone can take us a whole lot. Because then I have to ensure that all those online are following and are doing as they should. You understand? Making sure the person has been able to do the right thing before we move on to the next thing. So it takes a while to go through the plotting. Okay, so I may need additional time to do all of that. At the moment, you are how many are you? About 16 or so. So let me call the row. Abogula Desmond, Filawa Williams, Agboche Beauty,
Sir.
Ania Tales, Apia Kubi Elijah, Benon Emmanuel, Ochre Edward, Emmanuel Do,
Sir.
Emmanuel Chumasi, good, Manu Simon, Mohammed Ibrahim,
Sir.
Nonita Andrews,
Sir, I'm here. Andrew.
Nyame William, okay. Then Ilyasu Aloriba, we
Yes.
have Pius Atambiogo,
I'm
then
William.
Sashi Emmanuel, good. I think more people have joined. Let me see who they are. If you didn't hear your name, draw my attention so that at least I can mention your name as part of the recording.
Mark, I don't hear.
Okay, because you didn't hear Mark.
Yeah.
That was the last name I mentioned. Emmanuel Chumasi, then you were not paying attention.
Okay.
I mentioned Emmanuel Chumasi, I mentioned Emmanuel Doi, I mentioned Sechimak. Sechimak was even the last one. All right, so these are the people I have. I wonder whether that is all that there is to attend this meeting. Okay. So today we're looking at chapter 2.
Please say you didn't mention my name, Florence Tetten.
What's your name? What's your
Florence
name?
Tetten. Florence Tetten.
Oh, you just joined, isn't it?
Yes, please.
Yes. Then say I just joined, so acknowledge me so that I will acknowledge you. Okay, so let's welcome our sister Florence. All right. So we are starting for chapter 2. And chapter 2 is still on surveying. And this time we're talking about measurements in surveying. What type of measurements do we undertake in surveying? All right. We undertake, as we noted last week, we undertake linear measurement and along the line angular measurement. That is when we get to cartography proper. Okay, you do. Did I say cartography? Compass traversing. You do angular measurement. All right. So you start by measuring. As for the linear, it is obvious whether a chain or compass. You do linear measurement. So one significant or major difference between linear measurement, chain surveying and compass surveying is that chain surveying does not do angular measurement, whereas compass surveying or compass traversing does angular measurement. So because linear measurement is uniform, in other words, common to the two, we are focusing now on angular measurement. So angles, that is the beginning of chapter 2. Angle or angles. What is an angle? What is an angle? It is the measurement of either of the two arcs between two directions formed at a station by two survey lines meeting at that station. I'll break it down. The measurement of either of the two arcs, ARCS, that's what the word I'm using now, arcs, between two directions formed at a station by two survey lines meeting at that point. That is so it's a very common word. So we measure angle or we mention angles. Everybody is aware what angles are, but we want to get our technical definition. And so the point here is that anytime you put even a point, like pencil, pen, you put a point there. All right. And let's say draw a simple line. Once you have drawn that line, all manner of angles have been formed. All manner of angles have been formed. All right. So if you draw another line, then the angles edge out very nicely. So, for example, you put a point there, you draw one straight line to the right. Let's say diagonal, it shouldn't be straight. Another one to the left, diagonal, it shouldn't be straight. So that the two lines will meet at a point and they are forming something like V shape. All right. You can try that now because I told you to get your notepad with you. Just put a point there, one diagonal line, all right, straight one, another diagonal line to the left, one to the right, one to the left. But the two of them should meet at that point that you placed. You find that you'll be forming something like a V shape. Okay. So inside the V shape, you have one angle formed. Then outside the V shape, you have another angle formed. And that's what we are saying that if you take the inside one, that is an arc. All right. Then the outside one, you can also have an arc. At any point, the two of them will give you a circle. And so you can calculate what angle the inside one is, what angle the outside one is. We will not go more into angles and how they are calculated and so on. We are only using angles to let you know that when you go to the field to do your survey work, you are going to form angles. And that anytime, because as I told you in chain surveying, we do triangulation, if you remember, triangulation. So anytime you form a triangle, remember that there are angles that have been what? Formed. And so at some point, you'll be required to measure those angles. Therefore, the two lines that you have drawn will give you two angles. So that is all about angles and the meaning I want to ascribe to them. Now, the point that you place, if you remember, before drawing the two diagonal lines, is the station. In surveying, there's something we call station. A station is a place where a ranging pole has been, planted. Last week I showed you I gave you a pictorial view of what a ranging pole is. As you move on, you will see it better. But now everything is online. So if you can go online, you see ranging pole. But ordinarily, those who have followed athletics, the ranging pole is more or less like the javelin. The javelin. But this time, as you move on, you hear the description. It has a pointed tip so that you can plant it into the ground. All right. So that point that you place there is a station. On the field, that point there will not be a point, but rather it will be a ranging pole. A ranging pole. And from that point, you can have other ranging poles close so that they will form a triangle. That is all that I want you to know about angles. From there, the next thing to talk about is types of angles. This is what surveying has for you. We are not going deep.
Hello, sir.
But remember that, hello.
I wanted to ask if you can project your slide. If you are using slide, you can project it. So.
You were late. You joined later, so you didn't hear what I said.
Okay.
Mm-hmm. I am not using the laptop at the moment.
Okay.
I'm using the phone and the slides. This one goes with slides. The slides are not here with me, but trust me, I'll forward everything to you.
All right,
I hope
sir.
you have
Thank you.
seen the first chapter.
Yeah.
Good. So that is what the first chapter has. So as for this week, it will come earlier than the length of time that it took me to bring you the first one. It will come maybe by tomorrow next. You have the chapter 2, all of it. So don't worry. Just try,
Okay.
if you can, make some notes just to guide you within the 2 days that you go without the slides.
All right.
Okay, so
Thank you.
that is an. Now we are moving on to look at types of angles. Types of angles. In surveying, we recognize two major angles. Two of them. We have horizontal angle and vertical angle. Horizontal angle and vertical angle. These are the two angles we recognize in surveying. So what is a horizontal angle in surveying and what is, I know mathematics, they go so deep, do this, acute, what, those ones. And you are not going there. Uh-huh. Ours is just what I'm telling you, and that is what the requirement of the course is. So what is horizontal angle? As the name implies, horizontal. Any line that flows from left to right or right to left is horizontal. Okay. So in surveying, you can have an angle, all right, that is formed along a horizontal plane. That is to say that that angle is formed by two lines that are meeting at a point, one from the left, one from the right. They are meeting at that point. And the angle that will be formed is known as horizontal angle. All right. Then we have vertical angle. Vertical angle, as the name implies, a vertical line is a line from top to down or from down to top. That is a vertical line. And so we can have an angle formed over there. There can be a station, a point. One line will come from the top to join that point. One line will come from the bottom to join that point. All right. So they will form an angle over there. That is a vertical angle. Then maybe at the top of each of them too, you can extend lines either to the left or to the right. All right. So that you have an angle formed there. You can try it as I described. All right. So that angle is also vertical angle. Don't worry, we are not going to go deep into angles. We are not at all. So these are the two types of angles. I hope it is simple so I can continue. Let's move on to the next point. Now we're going to look at what we just saw are types of angles. We're going to look at kinds of angles for the two of them. All right. Or divisions of horizontal angles or types of horizontal angles. That's what I mean. Then we can also talk about types of vertical angles. So now we are doing kinds of horizontal angles. Kinds of horizontal angles. That's the first one we are doing. First horizontal angle is known as included angle. Included angle. Then the second one is deflection angle. Deflection angle. All right. So if you are by your writing desk, I will entreat you to, should I say, sketch a square. It can even be a triangle. Just sketch it so that you have a perfect triangle sitting down inside your notebook. I hope you are doing it. You are now 17. We haven't started the plotting. This one, I just want you to understand it. I know some of you are so mathematically good, and some of you, I know you are teaching EV maths, but that's not where we're going. We are only doing the class one things because surveying doesn't have to do. But if you do surveying to the highest level, surveying is more to do with mathematics. That's why we want to introduce a few. Yesterday, if you saw the write-up, I told you Makola calculator will do. You have to get Makola calculator along the line. Or you do 1 + 1, 2 + 2. And in the exam room or quiz room, you will not be allowed to take your phone there. So if you have your calculator, that's good. But this is students are now because some of the calculators are programmable. Okay, so I hope you have your triangle. Now you have a perfect triangle. Extend the baseline to the right. Extend it beyond where the angle has been formed. Beyond where the angle has been formed. Extend the baseline. I hope you know the baseline. Then extend each of the other lines, other two lines, if it is a triangle. If it's a square, extend each of the four to different directions. I hope you are following the instruction. And that is how online, that is how some of these things are done because you are not unable to demonstrate it. Okay. So inside the triangle or the square that we have drawn or the rectangle, if it's a triangle, you have three angles formed. You have A, B, C. If it's a square, you have four. You have A, B, C, D. All right? That's what you have. Now, those angles inside are known as included angles. They are known as included angles. All right? So, an angle that is formed inside the triangle or the shape by two lines is an included angle. So if you numbered it A, B, C, D, for example, your included angles are A, B, C, D, or A, B, C. Your included angles are A, B, C. Okay. So an included angle is an angle between two sides of a triangle or a rectangle. But for now, we use triangle more because so we talk more about triangulation. Then we go to deflection angles. Deflection angle. If you remember, I told you to extend each of the lines. If it's a triangle, extend each of the lines and let them face different directions. You will find that another angle has been formed. For example, what I have here between A or angle A, when I extended that line, another angle was formed outside. When I extended the line between B and C, for example, another angle was formed outside B. When I extended C and D, another angle was formed. And when I extended A and D, another angle, I'm using a square. All right. So you have four angles also outside because of the extension you did. Those angles are known as deflection angles. Deflection angles. So deflection angle is the angle at a point on the F between the direction of a vertical and perpendicular line. Between a vertical and a perpendicular line. All right. So that is what we call deflection angle. There are four, so they are deflection angles. And all of them are horizontal angles. All of them are horizontal angles. All right. So, and the horizontal angles, we have two of them, included and deflection angle. I hope that is clear for each of you. From there, you look at kinds of vertical angles. Kinds of vertical angles. Again, I'll let you do a simple sketch. I have included in the slides sketches in the course book. All right, so you have them just like they are in the course book. But I'll let you do another sketch for us to demonstrate kinds of vertical angles. We have we have angle of elevation. We have angle of elevation and angle of depression. These are the two kinds of vertical angles. Angle of elevation and angle of depression. Okay, so you're going to do another sketch. Put a point on any page, any sheet of paper, just a point. And then draw a horizontal line from that point, let's say to the right. Do it to the right, yes. Horizontal line, straight line to the right. And label that line A. Then draw another line from that same point in a slanting manner. This time to the top. So that line will lie on top of line A. On top of it in a slanting manner. It should slant. Or it should be diagonal to line A. Yeah, diagonal is better. It should be diagonal to line A. Then draw another one forming the same angle. This time down from that same point. Let it go down in a slanting or diagonal manner. Okay. I hope we have captured it all. All right. Now, do something like human eye at the place where you put the points, so that it is more or less like that eye is looking at an object. Okay, so at the end of, I forgot, the line that is slanting from the top, the diagonal line to the top, label it B. And the one down, label it C. Okay. And so make something like a human being or an eye at the place where you put the point. Something like human eye. That's why you do the less than sign, then you do an arc inside, and then you do some catches around the arc that will form an eye. Then at the end of line B, at the tip of line B, at the tip, you can write object. Then at the tip of line C, you can also write the word object. Okay, so simple. We're going to identify the two angles we mentioned under vertical angles. We said we have angle of elevation and angle of depression. From where the eye is, all right, now we have two angles formed because there's a vertical line, straight one, line A, and then we have line B, and then we have line C. Between line A and line B, an angle has been formed. Between line A and line C, another angle has been formed. So let's say the eye is looking straight at an object, that is line A. That is the line of sight. That's what we call line of sight. Now, should that person or observer or eye decide to look at something beyond the line of sight, all right? Maybe he's plucking cocoa, so he has to lift up the head and pluck it. Maybe he's plucking mango or orange, all right? Everybody has a line of sight. Wherever you're looking at, where your eye is going straight, that is your line of sight. Okay, so That person is observing an object over the line of sight. So between line A and line B, an angle has been formed. Because it is up, we refer to that angle as angle of elevation. Angle of elevation. So that is the first angle. Okay, so angle of elevation is the angle between the horizontal line of sight and the line of sight up to an object. Up, the operational word there is up. UP, up to an object. So from the horizontal line of sight, that is line A, and the line of sight up to an object. So you have moved your eye from your line of sight and you are now observing something up there. And so between your line of sight and the object you are observing up there, an angle has been formed. That angle is known as angle of elevation. Then we have angle of depression. That is the opposite. So should this observer or the eye, in this case the surveyor, should he decide to look at something down? Let's say an ant is biting the surveyor. Let's say something is maybe happening to the boot. Let's say the surveyor would want to look at the chain which has been laid on the ground. All right. So an angle will be formed between the line of sight and the object down there that the surveyor is watching. And so that angle is known as angle of depression. So between line A and line C, we have angle of depression. Therefore, the angle of depression is the angle between the horizontal line of sight and the line of sight down to an object. Down to an object. So these are the two kinds of vertical lines, okay, that we have as part of what we have to study. Remember, this is elementary surveying. This is elementary surveying. And so we are not going too deep. We are just scratching the surface. Later, if you develop the interest to pursue surveying, and it is, where I teach, I have a guy here who is a surveyor, even though he's not teaching geography. He's a surveyor. He did geography all right, but for a very long time, they made him teach social studies. So he's there with them. Okay, so later, if you have the interest, then you can go for training. You can go for, I'll find out from him where he had his training so that if you have time, you can do it. And as a teacher, you always have to find some additional thing to do. All right, don't be too dependent on what you do, what you have. Mine is what I'm doing. This is beyond or beside the normal teaching that I do. All right, between now and 9:30, I have to be with you. That is something different, something extra. I also do farming because I'm a full-blown Sefi. You know, Sefis are into farming full time. All right, so we are done with that one. We're going to, yes, any question? We are now 15. Okay. Any question? All right, let's look at the next heading. Angle measurement with the protractor. That is the next heading. So I told you last week that each of you should have his or her mathematical set. Yesterday, I don't remember the time, but I remember I communicated to you via WhatsApp that you should have your mathematical set.
Hello,
by
sir.
you. Hello.
My name is Eric Ajima. I joined, my network was disturbed, so I joined a bit late. I actually didn't know. I'm a bit lost. I don't know when the class started though, because we have 6:30. I have 6:30 on the timetable. I don't know whether you started just like last week, so that I know that what the lessons are or the things that I've missed so far.
But I think we settled that last week. Huh? Last week the same question came and we all answered. I answered and I think another person did that the original timetable given to me has 6 o'clock to 9:30.
Oh, okay.
Uh-huh. So
And
that's our.
I thought 6:30, so I joined 6:30. I think most of our colleagues also have the same problem, so they join by 6:30.
No, but even now the number is going out. Is going down. I started with 16 of you, now it's 15. So I don't know your number in reality. And you see, some people are too lazy to join some of these classes. They only show up when it is quiz or exam. And that is when they will go and face whatever. And I must tell you, some of you are careless, they care less about what you are doing. You are not the first group I'm teaching. I have been with the social studies group, and the first group, the cohort, the first cohort, I was with them throughout. Some of them, no. And even the social studies group, they are many. But the course rate tells me that when you print, because they are about 45, but for them, I have been meeting them face to face. And so we give them books. We print books, they order for 45. At the end of the day, some will not get because some people will never show up. So you will not count them among the class. They only come when they hear that books are coming. You come and buy the books, and that is the end. They only show up again when it is quiz. All right. So I don't think people are joining. I don't know whether it is also the network. So Eric, well, you have joined,
And
so
yeah. So, and also, I don't know whether today I actually wanted to make this suggestion. That's why I felt bad not joining early. If we can break it, because the Saturday, the Friday, the Tuesday evenings, for instance, it's I find out from one of my other course reps and then some people, it's like from the 6 to 9:30. Sometimes a bit on us, like the stress from work and other things. So I'm just pleading if we can just break it down, maybe today 2 and then today 2 hours, and then find some other time, maybe tomorrow 2 hours. That is to your discretion. To that it will actually
uh,
help us.
well, that's a suggestion. But we are also working with UCC. They have given us the time. You understand? And as we speak, there's recording ongoing. It is
Yes,
being recorded.
yes.
Because they need to show evidence that this work has been done, and that is what they will use to prepare the claims and so on. And so I cannot use my discretion to break the time into 2 different days. Maybe the best we can do is to take a short break in between because we are closing at 9:30 per the time given me. It should have been even 10, but they realized that 10 will be too late. All right, so they gave us 3.5. Usually, onlines are 4 hours. And so maybe after 2 hours, you can decide to take a short break, come back. But my fear last week was that if we decide to break, how many people will be eager to come back? You understand? Some may may quiet there, but by the time he's back, he's already late, and the class may even be ending. So, well, last week I thought of it and I decided why not. But if you so wish that today we break into it, take a short break, that's fine. I cannot use my discretion to break the class into 2 days. I don't think that because the recording will only capture 1 hour or 2 hours in that case. Then the day that we will schedule, um, it will not be captured. That means that I didn't do the full lesson that I should have done.
Say not not
So
not 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 that I'm cutting you short, but I think the previous blocks and semester there was lecturers like that who divide the time for us, and then I think the recording was done in that manner.
all
So
right,
that
so
is why
maybe I'll have to talk to the host, who I believe is online with us. Yes, I have to talk to the host and see if it can be staggered in that manner. But for me, if you take it once, it is quite okay because then you can use the other day for other stuff. So I have to discuss with him and see whether breaking into it will be fine for him. Mhm. And remember also that as part of the remedy to all these, I have requested for off the record time. That is to say, additional time that will not go on record. You understand? Because surveying the plotting takes a while. Now we're going to go on to how to use the protractor, how to orientate the protractor, because that will be the main tool for the constructions. If you are constructing angles, you should know how to move the protractor around. All right. And this one alone can take us so long. That is why I also told you to have it. So, Eric, that's all those are welcoming suggestions. I will carry them on board, talk to the host, whose number I believe is on my phone, and then see whether that is doable. If it is, I'll communicate to you so that we find the but maybe it might not be Wednesday because this same course I teach it. I am teaching it this same semester with the sandwich students on Wednesday.
Oh,
on
okay.
Wednesday, and I start from 5:30 to 7:30. Yeah, 2 hours, 5:30 to 7:30. Yes, on Wednesday. So it might not be Wednesday.
Oh, okay.
And then in that case, I may push you to.
And
If we do regards to the lecture as well, I'm also suggesting if the projection will always be done, because what you do, I'm sure, I don't know of others, but for me as a student, I'm sure I'm confused with regards to the construction. I believe maybe if the projection were to have
Well,
been
the thing that I then you are not following because I as for the projection, leave it because I've already talked about it. If you join us, that's okay.
done,
I've
Sir,
already
please,
addressed that issue.
can we add Saturday?
No, well, it should be a consensus something. You know, Saturdays. In fact, my weekends are even busier than weekdays.
No, is it?
You
Then
understand?
let's do it Monday now.
Monday, I'm okay. No, we
say,
haven't. I have to settle it. I have to settle it with the UCC guy.
and also, as I said, as I was saying earlier on, when we meet Cosfred, when we meet with the after the program, when we meet with the with code, and then some of this they also bring these suggestions out that we can actually talk it over with if we realize the class is too long for us, we can actually talk it over with the lecturer and then communicate with. So we have the host number. Some of the lecturers, for instance, we have to even tell them to record. So when we talk to them, as you said, and then they made themselves available, we can actually break it down. That is one suggesting that anytime
I don't.
we have a meeting with the
Okay,
management,
so
that's
let's
what they
end that
tell you.
one. I don't have any problem with we breaking it into two. Not at all. Unless maybe the only day I will not be available will be Wednesday. Apart from that, any other and Fridays. So Monday is available, Thursday is also there, and so on. So I'll talk it over with him and see. All right.
Okay, yeah.
I'll talk it over with him and see whether that is doable. Okay. So now
but before you go
somebody
ahead,
Pius was
like, I
saying
wanted
he was confused with that. Yeah, who is talking?
this Ilyasu.
Let's go.
Yes, I wanted to tell Eric that we are already done with 2 weeks and we have additional 2 weeks. So breaking it down to will not go. And you said you still need additional time to cover up. So if we are going to break it down, it's going to affect us, which means we need more time, and it will not happen. So let's try and manage and see what we can do. Then we'll get additional time for you to see what we can cover.
Yeah, because of the plottings.
Yes.
You understand? So well, that's a counter. That's a counter suggestion. So I don't know how the others will also
Even
feel
though it's
because
not convenient, but we have to.
okay. So let's move on.
Joseph,
You'll find a common ground
Joseph,
somewhere. All right. So we are on angle measurement with the protractor. I told you yesterday, last week, I mentioned it, that everybody should have mathematical set. And yesterday, I informed you via WhatsApp that you should also have your math set. I believe you have it now. This is mine. Listen to the sound. How we can hear the sound. That's my math set. Uh-huh. So you have to get yours now because you're going to look at how to use the protractor to measure angles. Okay, so the first point you have to note under this heading is that every protractor has two directions. Two. And I hope you know the protractor.
Hello,
The one that
sir.
is curved.
Hello, sir.
Yes.
Please, good evening.
Somebody has raised their hand. George. Okay, let me talk to the lady first. Yeah, good evening.
Sir, please, can you turn on your video so that we can see what you're doing?
No, I'm not doing it on the board though.
No, maybe on your sheet. If you could turn
then I have to turn the camera.
Yes.
I'm not doing it though.
Oh.
I am only demonstrating. I'll tell you what to do, and then because in that case, then I have to get a tripod or something, or somebody should do the video for me. I'll get time for everything. Don't worry.
Right.
I'll give you the slides that will capture whatever I'll tell you to follow. So you just try and understand it. The slides will come. Next week, God willing, I'll try and give you the screen. Right. I'll try and share the screen and see how it will work. Okay, so for now, just grab your protractor. I hope you know which one it is.
Yes, sir. Yes.
Have you gotten it? Okay, so from Edward, no, that's not Edward. From Desmond to Mark, no, Nelson, Vanessa. You are the last person on my this thing here. Have you all gotten your protractors?
Yes, sir.
These days, the protractors that come, I don't think I'm okay with them. They create some hole inside the end, so it creates a division in the line. That's not too good. Yeah, use the old one, the Marshall type. What I have here is Marshall. Okay, so your protractor. First thing you have to note is that every protractor is read from two angles. So from two directions. That is what you have to note. Number one. And so which directions are we talking about? You see, if you look at the protractor, from the left to the right, we have 0, then 90 will be in the middle, all right? Then 180 will be at the right. That is the outer one. That is what we call outer scale. Outer scale. I hope you have seen it.
Sir, please, it's outer hot.
Scale.
Scale, okay.
Then we have the inside one.
Scale.
That one starts from right. So if you look at the protractor, you see that from the right, you have 0, 10, 20, all the way up to 180. That one is inside. So we refer to that one as the inner scale. Inner scale. Inner scale. Okay. Then the protractor has a center. It has a center. You see, there's a perpendicular line with boldly written 90. Where that perpendicular line ends down there is the center of the protractor. Then we have what you call baseline or the 0-degree line. The baseline or 0-degree line. When we start using it, I will be mentioning these terms. That is why I want you to note what they are. So you see there's a line at the bottom. There's a line at the bottom. It crosses the 8 on the left and then it crosses the 8 on the right, a straight line, okay, from left to right. That line is what we refer to as the baseline or the 0-degree line. These are parts of a protractor. These are parts of a protractor. So we are going to try and see how to orientate the protractor, how to move it around, how to use it to construct angles. That's what we are going to use. But there was a hand up before the lady spoke. Oh, that person is all right. Okay. So you are going to have a certain angle. You are going to have a certain angle. And that angle is what you are going to use to practice. I'll give you several of them. Several of them. Let's start with 80 degrees because that is what has been used in the book. Let's start with 80 degrees. How would you construct 80-degree angle? How? How would you construct 80-degree angle? Maybe I have to specify using the inner scale. Using the inner scale. So every straight line is drawn with a ruler because there's a saying that use the right tool for the right job. All right, then pick your ruler. Pick your ruler. Okay, draw a horizontal line to any length of your choice. A horizontal line is the line that runs from left to right. A horizontal line from to any length of your choice. Okay, I hope that has been done. And remember that we draw only with pencil. You don't draw with pen unless otherwise told. You draw with pencil. Okay, having drawn that horizontal line, mark maybe any part. It can be any part, but now as you are starting, let's mark the center of that line you have drawn. The lines will be different in length because we are not all using the same length. To mark the center of the line you have drawn. I'm telling you, or should I say, I'm teaching you how to use the protractor to construct 80-degree line. Okay. So now that you have the center, you mark it with a small mark, a small vertical line, small vertical, short one, less than a centimeter. Maybe 0.2 centimeters, not too long. On that line you have drawn, you can label the line AB, and the line can be labeled AB. Okay, that line you have drawn is your baseline. So how do you use that line to construct 80-degree angle using the inner scale? This is what you do. Simple. Very simple. Put the perpendicular. I know some of you teach maths, but we are going gradually. And so these things are very common to you. Put the perpendicular line first. Put the baseline of the protractor on the line you have drawn. And make sure the perpendicular line, the 90-degree line, is sitting right on the mark, the center that you marked. Are you there? Okay, I take it that you are out there. Now with this, you find that you have the inner scale running from right to left. So start reading from right to left. You see that you have 0 on your right, 10 will follow, 20 will come, 30 will come, in that order, all the way up to 80. So when you get to 80, you see that the 80 more or less is corresponding to 100. So when you get to 80, you put a dot where the 80 mark is. Now that dot should be placed on your sheet of paper. I hope that has been done.
Yes, sir.
Okay, so now with your ruler, connect that dot to the center of the line AB. Connect that dot to the center of line AB. The mark you made on line AB. I hope that one too has been done. Okay, so the angle formed there is your 80-degree angle. In surveying, we don't use the compass type of angle formation. You have your protractor, so use it straight away and then off you go. So that is 80-degree line, and that is how to form or how to construct an angle using the inner scale. Let's try it with the outer scale, the same angle, 80 degrees. Let's try it with the outer scale, the same procedure. The same procedure.
Sorry, sir, I didn't say with the outer scale. What are we measuring?
I said 80. The same angle.
Sir, from right or left?
It means you didn't listen to what I said, though. Huh? I said we are using the outer scale. The first one was inner scale. Now we are using the outer scale to do the 80 degrees.
Okay.
Have you done it? It can be on the same line AB.
Yeah, we are done.
Okay. Anybody with any trouble? Anybody with any trouble? Okay. So that is how to do orientate the protractor. All right. Now, using the outer scale, construct 100 degrees angle.
Sorry, sir, I have a question.
Okay.
The one we just finished, the 80 degrees using the outer scale. I'm sure we'll connect it to the baseline as well as we did for the inner scale.
Oh yeah, sure.
Okay, thank you.
Okay, so construct another line and try with 100 using both scales. If you encounter any problem, you draw my attention quickly so that we all be on the same page. So use the two scales, that is inner scale, outer scale, to try 100. To try 100. Alex, welcome.
Thank you. So I was on,
And
but
now
my
joining.
network, because of the network, I left and then I rejoined.
Okay. In fact, well, chapter 2 and the other chapters is the reason I said if anybody refuses to join, the person will struggle because you will not understand a few of the things there, even though they are not difficult at all. Okay, so I hope you have been able to construct those lines.
No, sir.
All right. Yeah, hello.
So I've not been able to get it very clear. Well, what I'm getting is like the same as the other ones, or I've gotten an error somewhere. If you can clarify it for me.
There's no error. You are right. Because if you check, the one from the left coincides with 100 somewhere. The one from the right coincides with 100 somewhere. So you are right. There's no error anywhere. And in fact, you can even see it on your protractor that when you were constructing 80, you saw 100 matching on to 80 perfectly. So if it is the inner scale, the 80 will match on to the 100 on the outer scale. I intentionally give you 100. If it is the outer scale, the 80 will match on to the 100 degrees on the inner scale. So you are right. They are the same, like that. I intentionally gave 100.
There is a asking whether from left or right.
I said do the two.
I did so that there is a asking whether from left or right.
I said use the two. We have one outer scale, one inner scale. So I said for 80, use the outer scale to construct angle 80 degrees. Use the inner scale as well. Then 100, the same thing. If you didn't draw another horizontal line, but use the old one, you find that they are the same lines you have constructed. That's why I'm drawing attention to the point that even on your protractor, you see that 80 is matching on to 100. If you are constructing 80 with the for using the inner scale, 80 will match on to 100 on the outer scale. If you are constructing 80 with the outer scale, 80 will match on to 100 in the inner scale. So it's the same lines you constructed. I intentionally gave that. Okay. So with this small exercise, we're going to move into another segment of chapter 2, which is known as bearings. Bearings. Okay. Bearings. Sometimes you can tell somebody you have lost your bearings. You have lost your bearing. That means that the person is lost. He doesn't know where he's moving to. Okay. So that same word, that same term is also used in surveying. All right. Now, anytime you hear bearings, we're talking about angles. Angles. All right. The angles can be clockwise or anti-clockwise, formed by the north or the south direction. Formed by the north or the south direction. So this is the meaning of bearings. It is the clockwise or anti-clockwise angle formed by the north or south direction. Clockwise, anti-clockwise, formed by the north or south direction. As we move on, you hear the word direction, direction, direction. In cardinals, in bearings, our directions are north and south. Those two cardinal points are our directions. And so all bearings are taken with any of these directions as the datum or as the reference point or as the starting point. All right. So if you are quoting bearings, we quote it as if we started, or we quote it with north or south preceding whatever we are quoting. If you are measuring, we measure using the north as the starting point or the south. Remember that if you have cardinal points, which right about now I'll tell you to do. So draw a vertical line. Everybody, vertical line. That is from top to down. That is a vertical line. I hope you are done with that one. Then cross it with a horizontal line. Cross it with a horizontal line. That is, let the horizontal line cross if you are drawing cross. Okay, but they all should have equal lengths like that, so that you have all your cardinal points on them now, or on the lines you have drawn now. I hope you are there.
Yes, sir.
So, okay, so let's label them. And I'll also be using meridian a lot. The word meridian. Meridian. So I hope you are aware. You know what a meridian is, or you have heard of that word before, meridian. In bearings, our meridians are north and south. In time calculation, we use north and south, okay, as we refer to those places two as meridians. So the line running from north to south is a meridian. That's why we call them longitudes. Okay, so you use these two quite a lot. Therefore, you need to be abreast with it. So meridian, top of it is the north. Top of your meridian, that is the vertical line, is the north. So you write N. And then down the meridian is your south. You write S. Okay. Then you have to your right of the horizontal line. That is your east. Then to your left, that is your west. Last week I told you that anytime you are facing any direction, your right hand side is your east and your left hand side is your west. So we have the 4 cardinal points were represented on the lines that we have drawn. On the lines that we have drawn. Okay, so in measuring angles, we use the meridian. We use the meridian north or south, and then we also use a given line. A given line. That given line is known as azimuth. I said that given line is known as what? Azimuth. A-Z-I-M-U-T-H. So you hear this word also a lot as you proceed. Azimuth. A-Z-I-M-U-T-H. A-Z-I-M-U-T-H. Okay. So now that you have your cardinal points, I can tell you to find any angle at all. All right. Now, when you find that angle, you will place a point there as you did. After placing the point, you connect that point to the center of your setup of your cardinal points, the center of it. That is where the north, south, east, and west lines are meeting. That's the center. That line that is connecting the center is known as azimuth, or a given line, azimuth, or a given line. So these are terms that you are going to hear.
Sorry, sir.
Therefore,
Listen, if the azimuth that you are talking about, is it any different line you are constructing aside the 4 cardinal points linking to the center? That's the azimuth, or the cardinal, the center of the cardinal points is the azimuth.
I said a given line. A given line. So if you construct that line, it is not the center. I said you are connecting that line to the center. That line is the azimuth. Are you all right?
Yeah, I'm clear now.
That line, yeah, is the azimuth. So the acute angle measurement relative to a given meridian, such as true north or magnetic north, and it is taken from the north or south towards the east or the west. Now, in bearings, as I said, we use the meridians as a reference point. Okay, and then the east and west will be our directions. So you hear meridian direction, and then I have defined azimuth also for you now. Any line on the cardinal points that joins the center is what is an azimuth. Okay, so you can represent your angle as you're talking about bearings. You can represent your angle with letter N or letter S. And when you are done with that one, you now come in with the direction. So if you are quoting bearings, we quote the meridians first before the direction. We will do series of examples, and that's why I will need more time because for you to understand, because it's not face to face, it will take a while. All right. So this is just the beginning. This is just the prelims. I'm moving on from this starting point to go and talk about two types of bearings. So we are looking at types of bearings. Types of bearings or systems of notation. Now we understand bearings. You know which one is meridian, which one is north, where to place the north, where to place the south. Okay, that is just the beginning. We are moving to the next point, which talks about the types of bearings. The types of bearings. We have two types. We have whole circle bearing, whole, W-H-O-L-E, whole circle bearing, and reduced bearing. Whole circle bearing is abbreviated as WCB, and reduced bearing is abbreviated as RB or QB. Reduced bearing is also known as quadrantal bearing. Reduced bearing is also known as quadrantal bearing. Okay, so take note of these two. Now let's start with the first one, whole circle bearing. Note that whole circle bearing is also known as azimuth. Whole circle bearing is also known as what? Azimuth. That means that when you talk about whole circle bearing, we are looking at a situation where you are supposed to construct a certain angle on your cardinal points and connecting that angle to the center with a line. So when that line is constructed, that line is your azimuth. Now we say whole circle because that whatever the angle, it can be found from north to north. Because you know that north is 0 degrees. I hope everybody is aware of this. And north is at the same time 360 degrees. And so nobody can give you any angle beyond 360. It's just like percentage. Percentage is up to 100. And so you cannot say you have gone beyond 100. That is we can have 200, but that is when you are doing your other calculation. But in learning If I tell you to do something in percentage, your figure is 100. If I tell you to do something in degrees, your reference figure is 360. All right. And so the whole circle bearing is also known as azimuth. Now, this whole circle bearing is the normal angle construction that you know. So you can be told to construct 30 degrees, 10 degrees, 15, 118, 112, 113. Any angle at all. You can even be told to construct 182, 183, 275, 279. All the angles from 0 to 360, whichever one you be told to construct. All right. After constructing it, the line that you would draw where the point ended, where you place the point to join the center, that line is known as azimuth. It is whole circle bearing because in this bearing, the reading starts from 0. The reading of the bearing starts from 0. Okay, so if you are told to construct maybe 183 degrees, 183 from where? Where are you going to start the reading from? From 0. So as soon as you start from 0, at that same point where you have 0, that is where we also have 360. So it means you are dealing with the whole circle. That's why we call it whole circle bearing. I hope that is clear. So that is the meaning of whole circle bearing. And don't get confused. It is just the normal bearings that we do. Construct this angle like what we just did, 80 degrees, 100 degrees, like that. Okay, that's about it. But in bearings, one thing you have to note is that if you are told to construct an angle, we are talking about clockwise, not anti-clockwise. Clockwise. If you get to a point, we shall do the anti-clockwise. That is when we're talking about forward bearing and back bearing. But for now, if you are told to construct any angle, we are talking about the clockwise movement. Clockwise movement. Because you start from 0 and then move from that point down. Therefore, if you go back to the cardinal points that you drew, let's label them. Where you have the north N, write 0 degrees and put comma there, write 360 degrees. Okay. Those are the 2 degrees there. Then from there, from north, your right hand side is east. Okay. And that is 90 degrees from the 0. So east, you write 90. I know some of you are very conversant with this. East, you write 90 degrees. Then from east, the next point you go is the south, where we have S. That one will be 180 degrees. 180 degrees. Then from the south, we go to the west. The west will have 270 degrees. 270. Then the fourth circle is what we have written already, 360 degrees. So in between, from north to east, we have 90 degrees over there. So I can tell you to construct 1 degree. I can even tell you to construct 89.5 degrees. Then between east and south, and that is where the mistake will come. In bearings, you don't mention the direction before the meridian. We mentioned the meridian before the direction in bearings. So I am moving from north. I said between north and east, we have 90. I'm down with north and east. I am moving from east to the next point. So it should have been east-south. That is wrong. That is tautology. In bearings, you mention the meridian first. So the closest meridian is south. So here it is southeast, not east-south, even though I'm moving from east to south. Okay, so between south and east, there's another 90, and that will give you 180 degrees. That is the protractor. Then from south, I know why I'm going this way, because these things are common, everybody knows them. I know why I'm going this way. Then from south to west, All right. You have another 90, where I can even tell you to construct 269 degrees. Then I'm moving from west to north, but I will not mention west to north. I'll mention north to west. That will give you what? Another 90. So the whole of it is what? 360 degrees. And so any angle that you construct on this 360-degree circle is known as co-circle bearing. And the bearing is written in the same way you were told to construct it. Let's say you were told to construct 275. All right. And so your azimuth is what? 275. All you will do is to get a line, okay, connecting the zero, that is the north bar, that is the meridian, all the way to where the azimuth is. So, for example, you constructed 180 degrees. All you do is to get a circle all the way to hit the south line, that meridian, and then you put there an arrow. That's all. So, if you are told to construct any angle, that angle is known as azimuth. That angle is known as azimuth. Okay. So let's do one exercise with regards to azimuth. With regards to azimuth. And I've told you, if I mention the angle, you are doing the clockwise, bearings clockwise. So with our cardinal points, let's do 45 degrees. Now we know how to move the protractor. Let's do 45 degrees. Let's construct 45 degrees. After that, let's connect that 45 degrees to the center of our cardinal point, and that will give us the azimuth. I hope you are on it. Some people come and go like that too. At the point you are 18, at the point you are 16, at the point you are 17. Oh. Noah, you just joined. George Dennis Sobin, you also just joined. Jason, you also just joined. Nyame William, you are also Abafufo. Vanessa was late today.
Sir, no, I've been there since beginning. You mentioned my name at the beginning.
Okay, that's good. What about Noah? Noah,
Hello, sir.
Okay. Yeah, Noah, you are there.
Yeah, I'm there, but just that I was on board, so I just alighted.
Then you have issues because these things they go systematically.
Yeah, I have been seeing you about 20 minutes now.
Okay, that's all right. Okay, then get closer to your table, get your pen, get your pencil, your mathematical set.
Yeah, that is true.
Let's
I'm
continue.
now walking. I'm in the streets.
Okay.
I'm walking.
Okay. Okay. So, yeah, who is having issues? 45 degrees. Now, how would you orientate your protractor? Let me help you do. Maybe some people may struggle with it, but it is that simple. Put the baseline of the protractor on the meridian line. That is the vertical line. The baseline on the meridian line. Let the perpendicular line, that is the 90-degree line, correspond to the east. Let it lie on east. The east line. Then read from left to right your 45 degrees. So when you see the 45 degrees here, you see the marks on the protractor, you put your pencil where the 45 degrees is on the paper. You mark that point and then take away the protractor. Then you reach out for your ruler. You connect that point you made to the center of the cardinal point. Okay? And that becomes your azimuth. You can label that line you have just drawn as A. And you can also label the center of your cardinal points as 0. O, not 0, O. O. So you have line OA. So your line OA is your azimuth. Your line OA is your azimuth. Next time, you can be told to construct maybe 185, 182. Now, when you have done this, you are not done. You are now coming to draw a circle, an arc from north all the way to come and hit the azimuth you just drew. And when you hit it, you make an arrow there. That is your azimuth. So line OA is an azimuth. Line OA is an azimuth. Okay. That is it. And so you can do for all the other one. Let's try another thing beyond 180. Let's do 183. Let's do 183. Anusha, okay, Bendodo. Let me change it from 183 to 191. 191. 191 angle. How are you going to proceed? How are you going to get 191? It is the same protractor. Now, anytime the angle you are looking for is less than 180, listen carefully. Anytime the angle you are looking for or the azimuth is less than 180, I call it stomach. The stomach of the protractor must point or must go to the right. Just as you did for the 45, for example. Because it was 45, you saw that the curved part of the protractor went to the right. And we read from the outer scale and we got our 45. Now, and the opposite is also the case. Anytime what you are looking for, all right? Anytime what you are looking for is beyond 180, it's more than 180, okay? The stomach of your protractor must be to the left. I mean, the curved part. So I said 191. So what do? 191, you already have covered 180. So you leave the 180 alone. You leave 180 alone. Just leave from north to south alone. That is 180 captured. So between 191 and 180, how many degrees are you supposed to add for you to get the 191? You will find that you need just 11. You need what? Just 11. I hope you are with me. So if you need just 11.
Meaning the 191 is going to be at your southwest.
Yes, exactly.
Southwest.
It's going to lie in the southwest. Yes, you know, if we haven't gotten there, that's why I'm not using those terms.
Okay.
So your 191, you have already captured the 80. From north to south is 80. So as she mentioned, your 191, your 11 left for you to get the 191 will be between south and west. So what do? You let the curved part of your protractor go to the left. In other words, let the perpendicular line of the baseline of the protractor lie on the vertical line, the meridian line. the north and south. Let the perpendicular line of the protractor lie on the west line. That is the horizontal line. When it happens like that, you are good to go. So now you read your 0 because you are looking for 11 pair. You find that your 0 will be lying on south. All right. So you start reading from south all the way up to where you see 11. Then you put a point there. You put a point there. You put a point there. Now, if you put that point there, that point is 11. That point is 11. So you connect that point to the center, and that is your azimuth. That is your 191, and that is your azimuth. When you are done, you now draw a circle, small one inside, not a big one, small circle with your free hand. All right, small circle from north all the way, from the meridian line all the way to come and touch your azimuth, and you have your 191 angle constructed. That is how to construct it. I hope you have captured that one. 191. We are going to construct 272. So let's make it 281, for example. 281. 281. So what do? The same approach. You have already covered 180 from north to south. You have also covered another 90 from south to west. That is 270. But we are looking for 280. Did I say 285? We are looking for 281 or 285. Let's make it 281. You are looking for 281. That be 289. 289. 289. So how many degrees would you add to 270 to give you 289?
19.
You have to know that 19. Okay. Now, because you have covered 180 from north to south, because you have covered 270 from south to west, you only need 90. So what do? How do you position a protractor? The curved part of the protractor will face the north, will go up, will go upwards. So your starting point for 289 will be the east-west line. Therefore, you place your protractor, the base line of your protractor, on the east-west line. And then the perpendicular line of the protractor will lie on the north-south line. I hope that is clear. Then from west, you are now going to read from west. From west, you're going to read only 19 because you already have 270. You already have 270. You are looking for 19 to add to the 270 so that you get your 289. So you start reading from west. So now you find that the 0 is now corresponding to W west. So start reading from that point. When you get to 19, you place a point there. And remove the protractor, use your ruler, connect that point to the center of the cardinal points. That is 0. The O, you connect it to O, and that is your 289 angle. And that is your azimuth. That is your azimuth 289. When that is done, you draw your small circle inside from north all the way to come and touch the 289 line and make your arrow. You are done. You have constructed your azimuth. So we are doing all this to help you know how to move the protractor around. Depending on the angle you're supposed to construct, you move it around in this manner. You move it around in this manner. Okay, I hope the orientation is done. Let's move on to talk about another another thing. Okay, so we are done with whole circle bearing. That is all about whole circle bearing. The normal angle you construct. The only difference is that you have your cardinal points, you connect it, and the line that will connect the O to whatever distance is the azimuth. That's all. So that is what you call whole circle bearing. And that is to say that it is whole because the reading starts from the zero on the circle all the way up to wherever you constructed your angle. That is what it is. Whole circle bearing. Well explained. Any question? Jerry, is it okay now? Good. We are going to the second type of bearing known as reduced bearing or quadrantal bearing. Reduced bearing or quadrantal bearing. Okay, so let's move. The same cardinals, north, south, east, and west. Now, if you observe carefully, you see that the north, south, east, and west has given us 4 divisions. It is a circle, but it has been divided into what? 4. So between north and east, we have 1 division. Between south and east, we have another division. Between south and west, we have 1 there. And the last one is between north and west. Another division. So 4 of them. Now, each of these 4 is known as a quadrant. Qua means 4. Anytime you hear the word qua, quadruple, quartet, anywhere that begins with qua means 4. And so a quadrant is 1 out of 4 divisions. So quadrant on what we are doing here is 1 out of the 4 divisions. So north to east is a quadrant, southeast is a quadrant, southwest is a quadrant, and then northwest is also a quadrant. Northeast is known as the first quadrant. Northeast is known as the first quadrant. Now, this northeast is lying between 0 and 90 degrees. It's lying between 0 and what? 90 degrees. So any angle that will be talked about, that will be formed or that will be constructed, is constructed between 0 and 90. And that lies in the first quadrant. Then southeast. Southeast is in the second quadrant. Southeast is in the second quadrant. And that is between 90 and 270 degrees, 90 and 180 degrees. So if you form any angle, it is either more than 90 or less than 180 degrees or up to 180 degrees. Either more than 90 degrees or less than 180 degrees. That is in the second quadrant. Then southwest is the third quadrant, and that is between 180 degrees and 270 degrees. So anytime you hear any angle between 180 and 270, bear in mind that you are dealing with the third quadrant. And the last quadrant is the northwest, and that is between 270 and 360 degrees. 270 and 360 degrees. So if you form any angle, it is either more than 270 or less than 360. So these are the quadrants. That is why this bearing we're dealing with is known as quadrantal bearing or quadrantal system, because every quadrant, quadrant 1, quadrant 2, all the way up to 4, each quadrant has its own guidelines. Each quadrant has its own rule that applies. Okay. And if you listen to the first name, it is known as reduced bearing. Reduced. So the azimuth that you form, let's say between north and east, is going to be reduced. And that means that we are going to apply a certain rule. Every quadrant has its own rule. We're going to apply a certain rule to reduce it into quadrantal system. All that I'm saying is that in each of the quadrants, we have a rule. Over there, we don't just quote the bearing like 90 degrees or 45 or 50 or 60. No. If it is 60, a certain rule will come in to reduce it so that it will conform to that quadrant. If it is 90, 91, 92, a certain rule will come in to reduce it so that it will conform to that quadrant. So now that we know the quadrants, now that we know all the quadrants, I am going to mention the rules that apply in each of the quadrants. So if you hear an angle, quickly, you should be very fast. You should know that this angle lies in this quadrant. And in this quadrant, this is the rule that applies. If you hear one, let's say 120, you know it is lying in the second quadrant. If you hear 130, 140, 150, 160, 165, 170, you know it is in the second quadrant. If you hear 182, 180.5, 180.1, 180.15, you know it is in the third quadrant. If you hear 270, all right, 269.5, 269.9, 268, point so and so, whatever, you know it is in the third quadrant. If you hear 271, 282, all right, 290, okay, 300, and so on, bear in mind you are operating in the fourth quadrant, and each of them comes with its own rule. So I'm going to take them one after the other, quadrant by quadrant, quadrant by quadrant. And that is where the later calculation, the 1, 2, 3 calculation will come in. So if you are converting from whole circle bearing to reduced bearing, the whole circle bearing is the azimuth, the one we did earlier. Construct 30, now I constructed that type. That's the whole circle. Now, once you have constructed the 30 is in a certain quadrant. So in that quadrant, what is the rule? As soon as you apply that rule, you are changing that 30 into quadrantal form. That's why we said we have two. We have whole circle. That is the 30 we have been talking about, or 45, whatever. That one is raw. No subtraction, no addition. But as soon as you hear 45, as we constructed, you know that 45 is in the first quadrant. So how do I convert the 45, which is a whole circle, into a quadrant system? All right, into a reduced system. I have to apply a certain rule. So rule 1, quadrant 1. In the first quadrant, and listen, when the azimuth, you have mentioned azimuth, when the azimuth is between 0 to 90 degrees, so okay, it lies in the first quadrant. And the bearing is the same as the azimuth. The bearing is the same as the what? Azimuth. That means that if it is in the first quadrant, you are not going to convert, because the rule says that whatever the angle you constructed there, that angle is the whole circle bearing, all right. But if you want to change it into quadrantal bearing, that angle is the same. The quadrant version or the reduced version is the same as the azimuth. So the 45 you constructed, if you want to change it into quadrant, if you want to apply the rule is saying that the whole the reduced version or the quadrant version of the 45 should also be what? 45. And so any azimuth that lies in the first quadrant, okay, any angle that lies in the first quadrant is equivalent in the reduced quadrant or in the reduced system is that same angle. So it can be 1, it can be 1.5. That is the whole circle bearing. The reduced bearing will also be 1.5. Later, I'll tell you why it is so. If it is 0.5, all right, the reduced bearing will also be 0.5. If it is 45.6, the reduced version will also be the same. If it is 50.9, the quadrant version will also be 50.9. So over there, nothing changes. Therefore, if I give you an azimuth, any angle at all for you to construct, and when I finish, I tell you to convert it into quadrantal bearing or reduced bearing. Don't worry your head. It is the same angle you constructed. That is quadrant 1. Okay. Now quadrant 2. Quadrant 2. Over there, the rule changes. The rule changes. So listen to quadrant 2. When the azimuth is between 90 degrees and 180 degrees, the line or the azimuth lies in the second quadrant, and the reduced bearing or quadrantal bearing is obtained by subtracting that azimuth, by subtracting that angle from 180, by subtracting that angle from 180. Okay, and when you have gotten your answer, you are going to state it differently. Remember the whole circle, but we just say 30 degrees, 40 degrees, 20, 50, like that. You are done, nothing more, nothing less. But here, it is here that you're going to apply the meridians as well as the direction that I mentioned earlier. So if it is in the second quadrant, you know it is between 90 and 180. So whatever azimuth that will be given to you, if you want to convert it into quadrant or reduced bearing, you have to subtract that azimuth from 180. Why? Why must it be subtracted from 180? I told you that the bearings you're going to do are all dependent upon the 2 meridians. So whatever azimuth that will be given to you, the closest meridian is what you apply. So listen to this carefully. If your azimuth is less than the nearest meridian, I repeat, if your azimuth is less than the nearest meridian, subtract the azimuth from the meridian. That is one rule you have to know. If your azimuth, your angle, your whole circle bearing is less than the nearest meridian, subtract the angle from the nearest meridian. So for example, if I give you something like 179, 179, 179, you find that 179 is smaller than 180. The nearest meridian is 180. That is the south. But 179 is smaller than that one. And so the rule I just gave you is that if it happens like that, you subtract the angle, the whole circle bearing, from the nearest meridian. So here, your whole circle, your quadrantal bearing or your reduced bearing will be 180 minus 179. And it is going to give you what? 1 degree. True of us. That is true.
True.
It is going to give you 1 degree. But here you are not writing 1 degree, Pio. In writing your answer, you don't just write 1 degree. You have to bring the meridian and then the direction. So you quote the meridian, that is the nearest meridian, the one that you use in the calculation. Here it is south. So you quote S, then you bring your answer. You write 1 degree. Then you bring the direction. The direction here is the east, because the 179 that you dealt with is lying between south and east. So the meridian is the south, and then the direction is the east. So you quote the meridian first, and then you bring your answer, which in this case 1 degree, and then you bring the nearest direction, that is what? East. That is a quadrantal bearing. That is how you write it in quadrant form. That is a reduced bearing. That's how you write it in reduced bearing. You don't just write the raw answer, no. And unlike the first one where you just write whatever angle that was giving you, here you do 1 plus 1, 2 plus 2. So that is the first one. I can also give you something like 99.5. 99.5. You find that 99.5 is less than 180. And what I told you is that if your whole circle bearing, if your azimuth, if your angle is less than 180, or it's less than the nearest meridian, because as soon as I quote 99, you know you have gone beyond east, you have gone beyond 90. So you are now in the second quadrant, and the nearest meridian there is south, and south is 180. So you know that your angle is more than 180. So what do? You subtract your angle from 180. So it becomes 180 minus 99. What is the answer? Or I said 99.5, right? Okay, you for a start, let's use 99. What is the answer?
81.
Somebody's hand is up. Okay, that is pious. Good. Elias, your microphone is live. Do you want to talk?
81.
Tell us, see. Okay, so you get 81, isn't it?
Yeah.
Okay. So how do you write it? How would you write it?
It will be south.
Pious.
1 east.
South 81. 81 what?
81 degree. Degree.
If you don't bring the degree, you are wrong.
Sorry.
If you ask for this one, we are particular about everything. If you don't bring the degree, you are wrong. So let the degree come. South or S 81 degree. East. No, so that is your reduced bearing. So that is for the second quadrant. I hope that is clear. You be my mama assignment too.
Okay. So, sir. Hello, sir.
I'm here.
So let's assume it is a theory question, not as in objectives. Do you need to draw the bearing before you make the calculation, or you can just go ahead and calculate to get your answer without drawing it?
You need a drawing. You have to do your cardinals and show us the azimuth.
So without the drawing,
to prove that
be penalized, because it seems the answer would be the same thing.
It will be the same, but you are not just working maths, you are doing surveying. And so you deal with cardinal points. Therefore, show us the cardinal points.
No.
You understand?
Yes, sir.
Our interest is in the cardinal points, not just the answer. So that I will know that you understand what you're doing, and that you know where your cardinal points are, and that you understand your meridians and your directions, everything. You apply it religiously. So that's how you do it. Yes, Nyame, your hand is up.
Yes, sir.
Really?
Concerning the bearing, the one nearest, you gave like 179. And with that one, we subtracted 179 from 180. So we had one south 1 degrees east. So it means with the second quadrant, always we subtract it from 180.
Yes.
Okay.
That is the rule.
Okay.
That is the rule. And that's why I said that anytime your azimuth, your whole circle bearing is smaller than
180.
the meridian, you subtract the whole circle bearing, the azimuth or the angle from the meridian. So 179 is smaller than 180, as you said. So you subtract. That is in the second quadrant only. So now that you have understood the second quadrant, we are moving to the third quadrant. Third quadrant. You only have to be conversant with the rules like that. As you said, in the second quadrant, you subtract the azimuth from the meridian. Now, in the third quadrant, what do we do? Third quadrant. When the azimuth is between 180 degrees and 270 degrees, all right, the line lies in the third quadrant, and the bearing is obtained by subtracting 180 from the azimuth. You see that it has changed. So quadrant 2 is the opposite of quadrant 3, if you check. So apply your mind here. Quadrant 2 or second quadrant is the opposite of third quadrant. In the third quadrant, the nearest meridian will be 180. And in the third quadrant, all the figures there are more than the nearest azimuth. Because as soon as we hit 180, at 180, you are still in the second quadrant. But anything beyond 180, you are in the third quadrant, meaning you have gone beyond 180, which is the meridian number, the nearest meridian. So it can be 180.5. It is still more than 180. It can even be 180.1. It can even be 180.01. It is still more than 180. So what do you do? When it happens like this, you have to subtract the meridian from the azimuth. So if it is 180.01, you will subtract the meridian from 180.01. So it becomes 180.01 minus 180. I hope you understand that. If it is 181, it becomes 181 minus 180. You subtract the meridian from the azimuth, the angle that was given you. In the second quadrant, you subtract the angle from the meridian. In the third quadrant, you subtract the meridian from the angle. I hope you are following. So let's do some more examples there in the third quadrant. I've told you it is beyond 180. So maybe it's from 180 to 270. Maybe I'll give you 192. 192. That's your azimuth. What will be your reduced bearing? 192.
So please, 192, is it not in the fourth?
192.
So 12.
192 being the third quadrant.
It's in the third one. The third
you have to follow the area, no. Because you have done this gradually up to this time, so I'm surprised that I see 192 in there. Okay, so what will be your answer?
12 degrees west.
It will be
That's 12 degrees west. South 12 degrees west.
okay. That's correct. It's correct. So that is how it goes. I can also give you another one. 264. 264. What will be the reduced bearing of 264?
So it's south 84 degrees west.
It will be 84. Eh?
Yes, 84.
Yes, sure.
84.
Okay. Okay. So south 84 degrees west. What about 269?
So you say 2 what?
269.
South 89 degrees.
Somebody's microphone is live.
South 89 degrees west.
So that is how it goes. Very, very simple. Very, very simple. You get it? Very, very simple like that. And that is what we call quadrantal bearing or reduced bearing. So we are done with the third quadrant also. We are moving to the fourth quadrant. Quadrant number 4. Are you there? Are you there?
Yes, sir.
Okay. Quadrant number 4 says when the azimuth is between 270 and 360 degrees, the line lies in the fourth quadrant. Azimuth is subtracted from 360 to get the bearing. Azimuth is subtracted from 360. Remember what I told you earlier? That anytime your azimuth, your angle, your whole circle bearing is less than the nearest meridian, we subtract the azimuth from the nearest meridian. So if you check, you will find that quadrant 4 is the same as quadrant 2. The formula. So here we will subtract the azimuth, the angle given you from the nearest meridian. That is 360. 360. Because the nearest meridian is north. And having gone all the way from north to east to south to west, in the fourth quadrant, we are dealing not with 0 degrees, but 360 degrees. So it is between 270 degrees and what? 360 degrees. Therefore, if they give you any angle, any azimuth, any whole circle bearing, all right, in the fourth quadrant, you subtract that bearing because obviously that bearing, okay, that whole circle bearing will be smaller than 360, obviously, because 360 is the highest number, all right. And so if I give you two, 289, 289, you know, 289 is smaller than 360. 289 is smaller than 360. So you subtract 289 from 360. So it becomes 360 degrees minus 289 degrees. And your answer must be written with the north first, the meridian first, followed by the direction. Meridian first, followed by the direction. So let's try with 289. What do we get?
North 71 degrees.
It was 71.
North 71 west. 71. North 71 degrees west.
North 71 degrees west. North 71 degrees west. That's correct. And so that should tell you that any other angle that I'll give you, you follow the same pattern. And then off you move. If you forget, remember that quadrant 2 is the opposite of quadrant 3. Remember also that quadrant 2 and quadrant 4 use the same formula. We subtract the azimuth from the meridian. Okay, quadrant 2 and quadrant 4, that's what you do. And so if the two of them are the opposite of quadrant 3, then it means that in quadrant 3, you subtract the meridian rather from the whole circle bearing. Jason, your hand is up.
Yes, sir. Please,
right.
with the quadrant 1 and quadrant 3, yes, you can just go over it again. My line was actually breaking when we were explaining those one. Thank you.
You have gone past quadrant 1
and 3. Since the formulas are the same, especially quadrant 3. Because if I'm able to get 1, I can able to get 3.
No, the 3. What all that you said was that the nearest meridian is 180. All right, the nearest meridian is 180. And so the azimuth that will be given to you obviously will be more than 180. Therefore, you subtract the meridian from the azimuth. So in quadrant 3, we subtract meridian from azimuth. So quadrant 2 and 4, you subtract azimuth from meridian, nearest meridian. Quadrant 2 and 4. That is what you do. And quadrant 2 and 4 are the opposite of quadrant 3. So if you say quadrant 2 and 4 are the opposite of quadrant 3, what we are saying is that in quadrant 3, we subtract the meridian rather from the azimuth. That is all. So if I give you in quadrant 3, for example, if I give you 2, let's say 265. If I give you 265, 265 obviously is bigger than 180. So your calculation will be 265 minus 180. When you finish, you apply the meridian and the direction to the answer. That's all. And in quadrant 1, the meridian and the reduced bearing are the same. That was what we said. And I was going to go there because I told you earlier that I'll tell you why they are the same. I'll tell you why. And let me hear from you if you know why. Okay, let's dwell a bit on the quadrant 4. Now that at least I'm able to explain quadrant 3 and 1 to him in a way. Let's dwell a little more on quadrant 4. I said that we subtract the azimuth from the meridian, just like what we do in quadrant 2. That's all. So I can give you 290, 291. I can even give you 359. I can even give you 359. It is a simple matter of 360 minus 359. That will give you 1 degree. That's all. Now call baby. I can even give you 359.5. So your answer becomes 0.5 degrees. That's all. In the quadrant 4. Okay. So those are the quadrant. Now let's go back to quadrant 1. I told you that in quadrant 1, the whole circle bearing and the quadrantal bearing are the same. They are the same. And question is, why is it that in all of the other ones they change, but here is the same? You only have to apply the meridian and the direction in your final answer. That's all. Why are they the same? They are the same because the nearest meridian is 0. Which in here, the nearest meridian is 0. And so whatever number that is there, okay, whether you are subtracting that number from the meridian, that angle from the meridian, or the meridian from the angle, it will give you still the same answer. So I made you draw 45. Let's say there you have to subtract 45 is bigger than whatever, so subtract 45 minus 0, you still get your 45. I hope 0 minus 45 is the same as 45, and I'm what? Mathematically. Okay, I don't want to, but if you were given, let's say, 51, it should have been, because 51 would have been bigger than where you started from. Because you started the counting from that point, 0. Okay, so it becomes 51 minus 0. It is the same 51. That is why the whole circle bearing and the quadrantal bearing in the first quadrant are the same. That is why the two are the same figures. I hope you have understood it. Any question? Because you are done. Yeah, Willie, your hand is still up.
So were you saying 51 minus 0? 51.
I'm only using it as an example.
Because I think the first quadrant is 45, that is highest. So I was wondering.
That who told you 45 is the highest?
The first quadrant.
45 is just an example.
Okay.
So what is your understanding? How have you understood it? Did you join later?
Very good.
When did you join?
I know that it has been divided into 4. The highest is 90. The whole circle bearing has been divided into 4.
Somebody help me, man.
Also, I understand.
And what the 45 is just any angle at all. So from 0 to 90, any angle can be quoted.
Okay.
I can even quote 89.5.
Okay.
I can quote 89.5. It is still within the first quadrant.
Okay, sir.
So if I quote 89.5 as the azimuth or the whole circle bearing or the angle, the reduced bearing will also be 89.5 because, as I told you, the nearest meridian is 0. So if it is 89.5 minus, let's say, 0, you still have 89.5. Does that make sense to you?
Yes, sir.
Correct. So that is all about it. On that note, let me give you the following. You will see it when I bring the slides. Let me give you the following examples to have a look at. Write the following azimuths down. And let's work on them before I proceed, because I will not come back to this again. So you need to understand them well. Azimuth 125 degrees. Azimuth 91 degrees. Azimuth 49 degrees. Azimuth 280 degrees. Azimuth 244 degrees. Work on them now. So you start with the first one. All of you work on it, and everybody will give.
Listen, can you mention them again? My network was breaking.
Azimuth 125 degrees. Azimuth 91 degrees. Azimuth 49 degrees. Azimuth 280 degrees, 280. And azimuth 244 degrees. So everybody will work the first one and give me answer. When we are done, we shall move to the second one. Everybody will give his answer in that order. What is the first one?
So the first one, south is equal to uh, south is equal to 55 degrees east.
South 55 degrees east.
Yeah.
Have I ever mentioned equal to in any of the answers before?
No, sir.
So
So
south is 55 degrees east.
okay. So that is the first one. Who had a different answer? Anybody? Okay. So you all had the same answer. Okay. Now go to the second one.
The south 89 degrees east.
South 89 degrees east. Any other answer? South 89 degrees east. I think I could be. Would you want to talk? Your microphone is on.
South 89 degrees east.
Okay. Okay. So that is the answer. But let me hear from anyone who got a different one.
So we had the same answer.
All right. Let's go to the third one.
North 41 degrees east.
It is what?
North 49 degrees east.
North 41 degrees east.
41.
49.
Yes, sir.
49. Okay. Any other answer different from this? Did anybody get a different answer from what they have given? Okay. So that is the answer. And you know why it is also 49. I just explained. Let's go to 280. The fourth one.
North 80 west.
North 80 degrees.
North.
If you don't bring the degrees, are wrong.
North 80 degrees west.
Okay. Any other answer different from this?
The same thing.
Okay, so that is the answer. If you got a different answer, then you need some help. Raise up your hand. Let's help you. Then the last one, 244.
64 degrees.
North
50 degrees
west.
west.
244.
Yeah.
What's the answer?
South 54
South
degrees west.
64 degrees
I heard
west.
north. I heard north from one of you. Okay, so that is.
South.
It should be south. Those are the answers, and they are all correct. That's good. All right. So we are done with whole circle bearing. We are done with reduced or quadrantal bearing. So anywhere you meet it, all it matters is to be able to apply the formula, which is easy. 2 and 4 have the same formula. Subtract the azimuth from the meridian. Okay. And then the opposite of 2 and 4 is 3. Subtract the meridian from the azimuth. And then quadrant 1, they are the same. Full circle, quadrantal bearing, they are all the same. So that is over. There are other skills I have to teach you, but I'll not do that until I have brought you the slides where you'll be dealing with decimals. Where you'll be dealing with decimals. Because in bearings, we have degrees, we have minutes, and we have seconds. Just like the wristwatch that we wear. We have hours, we have minutes, we have seconds, and we even have microseconds. Okay, so the same thing applies to bearings. We have the degrees, we have minutes, meaning that when a degree changes, it enters into minutes. And when minutes change, they turn into seconds. So next time, I'll bring us back and I'll let us see how to apply the minutes and then the seconds. All right. For now, I don't want to confuse you because of the little calculation that we have done. That is all I was talking about. That's why I said yesterday that you need some Makola calculator. Okay. There's a comparison between azimuth and quadrantal bearing. It's on a table. Once you have understood it, everything will be here. So when I bring it, you get to know. For example, azimuth varies from 0 to 360, but bearings vary from 0 to 90. If you check, you see that none of the reduced bearings or quadrantal bearings was more than 90. None of them. If you go back and check. So that is the range. If you apply the rule, the formula, none of them will give you more than 90 degrees and so on. All right. So, and the second one says that the azimuth require only a numerical value, number, 50 degrees, 30 degrees, 40 degrees, like that, only number. But the quadrantal bearing or the reduced bearing, you need number as well as what? As well as what? Letters. You use the two. North, so and so, east, south, so and so, that. You remember? You need the two. That's another difference. All right? And so on. So when I bring you the slides, which will happen probably tomorrow or maximum latest Thursday. This one I do not keep long because I'm not far away from my usual place, so I'll be home early enough to send it. All right. Now let's look at three other terms associated with bearings. We have what you call forward bearing or fore bearing. Forward bearing or fore bearing. And we have back bearing. Back bearing. And then we can also talk about observed bearing. Observed bearing. These are other aspects of bearing. So when we mention fore bearing, fore bearing has to do with measuring from one station to an adjoining station in the direction of traverse. In the direction of what? Traverse. You know, your traverse, when you are, traversing or measuring, like say bearings, you start from 0 and then move on and then move on. And so if a point is lying on the track in the clockwise manner that you are going, that point is a forward bearing. Forward. You see, when the clock is going, it is going forward, it doesn't come back. Okay. So forward bearing has to do with any bearing from 0 to 360. Anywhere that bearing will fall is what? A forward bearing. You understand? That is forward bearing. Then we have back bearing. Back bearing is where you are not going in a clockwise direction. These days you use digital watch, the digital one, the electronic one, rather than the analog. That's what you use. But if you use the analog, you see that you have hours, minutes, and seconds. The seconds will be moving like that. It doesn't go back. So that movement is what you call clockwise. Okay, and that is clockwise bearing. That is forward bearing. But if you have to move backwards, instead of moving like that, the way clock moves, but rather reverse your movement, we call it what? Back bearing. Back bearing. And this one, it is measured from one station to adjacent previous station in the opposite direction to the traverse. in the opposite direction to the traverse. That means that you are not going the way the clock is going. You are going back. All right. That is back bearing. I'm mentioning this because we shall do. Okay, you didn't do any exercise, but I only apply. I'll give you some formula very soon. That is back bearing. Okay. And the next one, as you mentioned, is observed bearing. Observed bearing is nothing but the bearing you had on the field. You went to the field to do some field work. As I told you, surveying is not a classroom work alone. All right, it's a field work. You have to go to the field, take the measurements before you come and sit down. All right, so there's a procedure. Go to the field, come back, do the computation or the secretarial work. And so the observed bearing is the bearing you had when you were on the field. That is the observed one. So you measured, you went to the field, a certain bearing was maybe 50, 60, whatever. That is the observed bearing. That is what you went to the field to bring home. You brought home that bearing. Okay. There's another one known as calculated bearing. Calculated bearing. Okay. Now, when you go to the field, you may get a bearing so huge that if you want to use it to plot, there wouldn't be any paper for that because the papers you plot on are just the A4, maximum A3. But you had a certain bearing that is so huge that you can't plot. You had something beyond 180, something beyond 270. You cannot use that bearing to plot. So what you have to do is to calculate, reduce that bearing, apply a certain scale. All right. And that scale that you apply will go for all the other bearings. Now, because you have reduced it or you have applied a certain scale, all right, that the final answer becomes calculated bearing. Pray that as I'm you can pray that the rain doesn't disrupt it. I need the rain though. I've had some drizzles. They started way back in the morning. Yeah, intimate talk. The bonfire said I'm on here. She said, I thought they are. Well, if only you can hear me. The only problem with that, I will not be able to hear you. All right. If only you can hear me, then we can continue. And also, it depends on how heavy the rain will be. If it is not heavy, then I can still continue. So these are the four terms, other terms associated with bearings. Okay, so as I mentioned, calculated bearing. You went to the field, you got a huge figure. So you say that, okay, I am deflating each of the bearings by 1/3. All right, by 1/3, meaning you are dividing each of them into 3 and take one. So let's say you had 150. 150 divided by 3 will give you what? Then you take one, like that. That is, so the final one that you take becomes a calculated bearing. That's what you are going to use to plot. And it happens. It's not only bearings, the distances that you measure, some of them may be too huge, all right, too long for any paper. And so you have to calculate, you have to reduce them using a scale. All right, so that is the end of bearings. We will come back to bearings later. We'll talk about bearings later. All right, but not now. But for now, this will be the prelims. This will be the prelims. From there, the next thing we're going to talk about is, if there are no questions, I'm praying we're able to finish this one too, this chapter. We're going to talk about distance and how we can measure it. Distance. Oh no, I said I was going to give you some rule. Maybe I wouldn't give you, because if I give maybe what, when you get the slides, you see the rules there. Whichever one you don't understand, you tell me. But let me tell you, say that the forebearing and back bearing of a line have a difference of 180. Take note of this. The forebearing and the back bearing of a line have a difference of 180. Okay, so that if you have a certain forward bearing, if they tell you to look for the back bearing, all you have to note is that there should be a difference of 180 between the two figures. All right, that is the preamble, but the specifics are as follows. One, if the forward bearing is less than 180, in you, if the forward bearing, that is the bearing along the lines of the traverse, okay, moving in a clockwise direction, if it is less than 180, to get the back bearing, you have to add 180 to the forward bearing. The forward bearing is less than 180. You want back bearing. What do? Add 180 to the forward bearing to get 180, to get the back bearing. So let's assume you had a forward bearing of 179, which is less than 180. 179. The rule says that if you are told to look for the back bearing of 179, you will not go and draw your cardinals and then do a back bearing and anti-clockwise one. No. All you have to do is to apply this rule. And the rule says if it is less than 180, add 180 to it. And that will give you the back bearing. And so 179, if you want the back bearing, you only have to add 180. Okay? You add 180. And what will that one give you? 259, isn't it? Remember, I say 179 plus 180. What do you get? Calculator. Hey, Omar Dana.
179 plus 1.
So we get 359.
359 degrees.
Akwame say 359. So 359 becomes your back bearing for the 179. That's your back bearing. Now, we said that the back bearing and the forward bearing, the difference should be 180, if you remember. The forward bearing of a line and the back bearing, the difference should be 180. So now that you have gotten 359.
Yes.
359. If you subtract the 179 from it, you have to get your 180 back. And that is the difference. You understand?
Yes, sir.
That will be the difference. So the difference between the two should be what? 180. That's the first one. Now let's move on. I'm going to the second rule. The second rule says that if the forward bearing is more, not less, it's more than 180, subtract 180 from the forward bearing in order to get the back bearing. I hope you heard that. The first one was less, to add 180 to it. The second one is more, to subtract 180 from it. So let's take example. 181 is more than 180. If I want the back bearing for 181, what do? The rule is that I have to subtract 180 from the forward bearing. So what is the answer?
1 degree.
1.
That's all. 1 degree. That is your back bearing. Sorry. That's your back bearing. So it can be 253. What is the back bearing of 253?
73
73
degrees.
Are you sure? Okay. So that is it. How did you get 73?
You subtract 180.
You subtract 180 from 253.
That's all. Now, what if the forward bearing is exactly 180? What do you get?
It will be the same 180.
180. That's all. That's all. That's all. So these are the rules about forward and back bearing. That's all. This rule is very important, so keep it in mind. We are going, it's still on chapter 2. We're looking at how to measure distances. How? How do we measure distances? And what is a distance? If they ask you what a distance is, nobody will do that in examination though. But a distance is the measurement of the interval between 2 points. Between 2 points in a linear sense. Okay? Between 2 points. The interval, measurement of the interval between 2 points, that is distance. And this measurement can be in an arc form or in a curve, what you call non-rectilinear. It can be non-rectilinear, such as if you have to measure a river, okay, and so on. That is non-rectilinear. It is not straight. But distance can also be straight. It is known as rectilinear. If it is straight, it is known as what? Rectilinear. So take note of that. Fine. That is all about distance in terms of definition. Let's look at types of distances. Types. Types. The first type is known as horizontal distance. And as the name implies, from left to right. Okay? From left to right. Basically on the surface. That is horizontal distance. Okay, so any distance you take from left to right on the surface is horizontal. The opposite is vertical. All right, vertical is from top to down or down to top. What you call elevation. Okay, so if there's an elevation, we use vertical measurement. These days, there are machines that undertake vertical measurement. All right, you don't have to climb a ladder, stretch a tape measure all the way up to the top. No, there's a machine. You put it under it, and it is able to give you the height of whatever you are there to measure. That is the second type. The third type is known as slanting distance. Slanting distance. All right. It is a slope. A slope is a slant. A slope is a slant. It is not flat. It is not straight. It's a slant. It is slanted or diagonal, if you like. And so in surveying, if you, just like we saw last week, if you encounter any slope, any slanting surface, you have to reduce that surface into a horizontal one before you can carry out the survey. And that is when the leveling or the level survey comes in. If you remember, where I said you mount a tripod, you put a level on it and ensure that the tripod is well balanced. And then you lay your chain or your tape over it. Okay, so you convert the slant or the slope into horizontal distance. That's about it. Now, what are the methods of taking measurements? How? You want to go and measure. You have gone to the field. By what means can you measure? In fact, our ancestors were so wise. They were so clever. That time, there was no tape measure. None. But they were able to measure. Let me give you the traditional ways. And even some of us came to meet it. You know your span, which I still use. Your span. You uses your fingers. You stretch your fingers like that. And you move like how worms move. That's your span. They use it a lot. When you were kids, you used to play in the sand, and we were using that to take the measurement. All right. Then you could also use your feet. Your feet. You'll be counting. One, joining the other, alternating like that, and you'll be counting. They use it a lot. They also use their strides. strides, stretching your legs, like what the referees do when they are awarding free kick, that type. And then you can also use what you call pacing. Pacing. You pace. You walk normally. You walk normally, but as you walk, you are counting the number of steps you are taking. All right. And I tell you, if you take 100 steps, about 50 of them will be of the same measurement. Like that. All these were ways by which they measured distance in the olden days. Today, new ones have come. New ways of taking measurements. Different ways. Apart from pacing, the next one I'll talk about is the what you call measuring wheel. Measuring wheel. Those of you have, you see, now that we are learning to become full-time geographers, don't just walk around anyhow. Observe whatever thing you do. Observe. I'll give you 6 W's that you have to answer each time you are at any place. Ask where. The question where. That is the starting point of geography. Where is it? Is the starting point. That was how geography began. Trying to locate objects, location, space. So ask where. Number 2, ask when. Number 3, ask why. Ask how. Ask who. These are the W questions. By the time you finish answering these questions, you might have gotten a full-time geography writer. So if you are walking around, don't just walk around. I'm referring to road construction. Those of you have been observing, when they are constructing roads, you see that they hold a certain wheel. A certain wheel. That's what they use to determine the kilometric distance. So they will tell you from here to that place is 1 kilometer. From here to that place is 2. They don't pick tape measure to measure. It is a wheel, so you'll be holding it and be rolling it on the road. As you move, it will be reading. It will be reading. So when you get to any community, it is able to tell you from where you started up to this time, it is 2 kilometers, like that. Okay, so the measuring wheel has what you call odometer. If you like, those who are in love, odometer. They use it to determine distance. Then we can also use the tape. The tape, which normally comes in a 30-meter length. You use the tape to take measurements. That is the most commonest. All right, you can use the tape to take measurements. Okay, and so in doing chain surveying, tape is the second one. As you move on, I'll tell you how the tape and the chain are used together. Okay, so simply, the chain is for longer distances. The tape is for shorter distances, such as offset. Offset. As you move on, I'll tell you about offset. Those of you who have gotten the chapter 1, the first chapter, you have seen a certain diagram there. Page 8. Is it page 8? Let me see. Oh yeah, a certain diagram. That is it looks more like a table with figures, lines, and so on. I haven't explained that. That was what I told you last week that I will explain. That's when we are doing chain surveying in full later in the book. So we can use the tape to do our measurement. As part of tape, let's look at how many types of tapes we have. We have the cloth one. The cloth. It looks more like cloth. It's very common. It used to be these days. Yeah, we are now more into the steel. We have the metallic one. You have seen the tape that can be folded. That is metallic. If you go to the carpenters, they sometimes have it. And then we have the steel, the one that makes kopo. Kopo. That is the steel one. And so, and then we have the invar. The invar is it's a blend between the cloth and then the steel. It is not too common though. So these are the types of tapes we can use. Another way to take measurement is by EDM or the total station. You remember total station? I believe you have seen it in the slide because I showed it there, the total station. If you look at the functions, you find that one of them is to take linear measurements. So we take distance, you measure with the tape. You measure with the EDM, sorry. You measure with the EDM. Okay. That is the total station. All right. Then from there, once you are talking about tape, let's look at errors in taping. That is, if you are doing chain surveying and you are using the tape, what are the possible errors that you are likely to encounter? You are using the tape. All right. There are about 5 of them here, 5 errors. And that means that we'll be ending chapter 2 pretty soon, very, very soon. 5 errors in taping if you are using the tape. The first one is known as proportional error. Proportional error. Okay, what does proportional error in taping? No, that is, hold it. And it is known as incorrect length. Incorrect length. Under the incorrect length, one of the types is proportional error. So the actual error is incorrect length. But under the incorrect length, we have proportional error. I hope that is clear. Okay. So what is proportional error? What is proportional error? Error that is equal to the number of chain lines you have run. Okay. So if the error occurs at one part, just at one part, it means that the more you use the chain, the tip to measure, the more the errors crop up. All right. So it is proportional to the number that you undertook. If you did 100, it means that error has occurred 100 times. It has occurred 100 times. Therefore, if it's a plus, it has added that error 100 times to whatever you measured. If it's a negative, it has subtracted 100 times from what you measured. So, proportional error. How do you correct it? You have to measure known distances severally. Okay, so you have measured before using different tapes. Now, from here to that point is, let's say, 30 meters. All right, confirmed. You have used about 3 different tapes, and they all gave you 30 meters. And so, to ensure that you don't accumulate that error, you apply the material. In other words, the tape that you are going to use, you apply it to that distance. You know it is 30. So let's assume you measured and you got 29.9. That means that there's an error somewhere. You got 30.1. That is an error. And that is how to correct or detect proportional error. Okay. Then we have, under the incorrect length, we have constant error. Constant error. And this one comes when the chain or the tape is skinned or broken and spliced together. You see, the cloth one, for example, cloth, if you send it to the field, the likelihood of it folding over is very high. You may not know. And so you'll be working with it. You'll be working with it. And it becomes constant because you didn't know, you didn't see that it has happened. You'll be working. So it becomes constant. It will be with you. You might think you have done this length, but you go home, it is either, it's supposed to be less than that. It will be less than that. In reality, you should have done far less. But because your distance is, folded, you have done far more like that. So under the incorrect length, we have proportional error and constant error. Okay. And how to correct the constant error? Let me run by you. How to correct it? It says you need to either add or subtract each time. All right. So do some addition and subtraction there. At some point, okay, this is it's not up to 30, it's 29.91. It's not up to 30. Let me round it off. That's addition. Okay, this one is 30.01. Let me round it off to 30. That is subtraction. So you add and subtract in that manner, just for it to balance out. Okay, so let's move to the next error. The next error is known as sag correction. Sagging. Sagging. It is tip. It is chain. And when you say something has sagged, it means the middle part has caved in. That's what you mean by sagging. Okay. Now this will come about when a chain or a tape is suspended. Suspended. That is to say, instead of the chain or the tape lying on the ground or running on the ground, it is suspended in midair, like what you do when you're doing leveling or level chaining. You understand? Your chain is in midair. All right. So the likelihood of it sagging, caving in is very high. And that is one of the errors in taping. You can also do the taping in mid-air, and so the tape will sag. All right. Let's say the steel one, for example, it can sag. Even the cloth one can sag, and so on. Okay, so that is the sagging. And how do we correct it? How do we correct the sagging? You have to apply tension. Tension. That is to say, stretch it. Stretch it very well, so that you are sure there's no sagging. Stretch it. After all, if it is a proper tape, if you stretch it, it will not add anything to it. You are only trying to let it be fully stretched, no addition. Stretch it, and you would have solved that one. Then we have tension correction. Tension. Tension. Tension means the thing is stretched too much to the extent that it is getting overstretched. All right? It is getting overstretched. And for the chain, if you stretch it too much, it is likely some of the rings will dislodge or will open up, and you are going to be in trouble. So tension correction. Okay. Now, how do we cater for this? Tension correction. You have to check your chain or your tape against a known distance. Against a known distance. That is to say, if you know from here to that place is 2 meters, just apply it. Let's see whether if you stretch it, it will get there or it will give you something different. That is how to correct it. All right. The last error in chaining, in taping, the last error in taping is known as temperature correction. Temperature. And here, as you know, temperature has to do with how hot or cold a substance is. That is temperature. Okay. And so the temperature can affect your materials. If you are using the steel tip, it is metallic. And so when the temperatures are too high, it can expand. It can expand or it may expand. And that is going to give you wrong figure. Okay. If temperatures are also too low, it can also contract. It can also what? Contract, and you have wrong readings. That one, you might not even detect it. But as a good surveyor, you should know that anytime temperatures are beyond normal, something happens to your main instrument, either the tape or the chain, as a elementary surveyor. Okay, so how do we correct this one? We need to make adjustments for the change in temperature. Okay, and so you have to know the exact effect temperature has on your material, so that if you know temperatures when they go up helps the material to expand, then you not go and use the material in the day or during midday. At least you start your work early, 6:30, you're already there. By 10 a.m. when the sun is so high in the sky, you close. You understand? On the other hand, if you know the effect of coldness is so high on your material, you don't have to go there early in the morning. At least you wait after some time, around 7, 8 that way, then you go and start. All right, surveying, elementary survey, you don't do it all throughout the day because your material, your instruments are under the weather. So if you decide to do it throughout the day, some of them will give you wrong readings. Okay, so these are 4 errors associated with tipping. If you are using the tip to measure distances in the field, these are possibly the errors that you are likely to encounter. All right, so that is also the end of our unit 2. That is the end of our unit 2. Next week, when we meet, we will look at unit 3, and there we shall go into the nitty-gritties of chain surveying, proper nitty-gritties. But before then, I'll give you the slides. Now that you have the slides, next week I may go back because I'll be then be teaching chain surveying. So I'll go back to the diagram I referred to and use it to explain all of chain surveying. So those of you who have not read it, please try and do the reading. Ima, your hand is up.
Please, based on these errors that we have discussed now, can we say that most of the surveyors' measurements in terms of land and other things are not the accurate measurement given?
Well, they are accurate in the sight of human beings to a large extent because every surveyor knows this. So you will not go and work at the wrong time. But as you mentioned last week, all measurements are inexact. It might be accurate, but it's not exact. And so, yes, the exactitude of it is in the bosom of the Almighty. So yes, some of them do shoddy work, but with the advent of machines, sophisticated ones, they are able to get the metrics right. They get the figures okay, right? So that is it. But you see, it doesn't mean all of them go to the field and experience these errors. You are made aware of them so that you guard against them. If it is sagging, for example, you know, if your tape is suspended, if your tape is not touching the ground, the likelihood of it sagging is high. So when you go to the field, even if it will suspend, you will ensure sagging doesn't occur like that. So to be forewarned is to be forearmed. You know about it, so you prepare against it, even as you go to the field. That's what you do as a good surveyor. Anymore.
Thank you, sir.
All right. So on that note, we're coming to the end of our lesson for today. Come to the end of our lesson for today. So Abdurrahman, Desmond Mba, Agboche, Beauty, Alex Abba, Benon Emmanuel, Dominic Barnes, Imado, Emmanuel Chumasi, George, Dennis Oben, Jason, Noah, Manu Simon, Mohammed Ibrahim, Nyame William, Eliasu Aloriba, Paul Atambiogo, Seshi, It's what? Okay, Pius. Okay, yeah. Mark and then Vanessa. I think that's the course rep. All right, that is how far we can go. It's already past 9. I think we have done
Okay.
quite a lot. But remember, we have 5 units, but we only have 4 weeks. So as I mentioned, we will need some additional time. So apart from Wednesdays and Tuesdays, and maybe this week Friday they will not be available. So apart from this week Friday, Monday I'm available. I'll be available any other day to be with you. Wednesday I'll be available. No, Wednesday I'm not because of my car. Thursday and Friday. So among the 3 days, please look for the or as somebody suggested weekend. Then we have to arrange because I did it with the first cohort. Weekend when I am not traveling, then early in the morning 7 sharp. And it's me yeah manabo bed 10. Then we close. That is when uh, that is if I'm not traveling or if I don't go for any social occasion. So you have to look at these days and start now because now we are halfway through the number of days we have to meet. We have only 2 more left. So we have to do it quickly in order that we can get those times to meet and get everybody informed about it. On that note, if there are no questions, we come to the end of our meeting. Thank you all very much.
Thank you.
Yeah,
So I
and
have
then
a
all my.
contribution.
Okay, go ahead, please.
Please, I have a question. With
Go
regards
ahead.
to the slides, I don't know if you are aware that we those studying your course, we are mixed up. We have geography students, we have people who are also minoring in geography and they are doing the survey. So it looks like the group that you often send the slides to, not all of us are there. So it's making it difficult for some of us to get it. I had to ask a friend who's
So,
offering geography major to send
okay.
the first slides to me.
No, but once you are all reading one course like this, there should be a common platform.
Yes, sir. There's a common
Because
platform for it. But it seems the first one.
because the platform that I was added to is what I use.
Yeah, you should
So
send
I
his number.
suppose
We'll add it.
all of you are on that platform, are you not?
Yeah, most of us
Yes,
are
all
on
of them.
that platform.
Then Vanessa, please try and add them to the group.
Okay, we'll do that.
I'll make sure you get the slides either tomorrow, latest tomorrow evening, yeah. Because I'm getting indication that I can go back home uh, soonest. So contact Vanessa, who is on the platform, and give your number to her so that she will add you to the group. Or Vanessa, if you have their number, you send the link to them for them to join. Yeah, I think she's sending the links. So try and join. All right. Thank you very much. May God bless all of us till next week. Bye bye.
Please, I have just posted the link. If you are not on the
All right.
group, please kindly join. I have just
Okay.
reposted the link. Thank you.
All right. Okay. So over to you, the one who posed the question. Let's meet next week. Bye bye.
Bye.
Please, if you are not on the
Bye.
page, please, I've